Welcome to Oracle APM tutorial series. Application Performance Monitoring, or APM, is a service in Oracle Cloud Infrastructure that provides a set of solutions including distributed tracing, real user monitoring, and synthetic monitoring. This recording covers synthetic monitoring, which is a part 5 of the tutorial. My name is Yutaka Takatsu. I am one of the product managers in Observability and Management Product Management team in Oracle Cloud Infrastructure. The tutorial consists of 5 different video recordings, which you can find in this Oracle channel. Each recording is about 20 to 30 minutes long. Please find the video links to other chapters from the description in this video. This is a recording of Part 5, Synthetic Monitoring. This is Chapter 11, Synthetic Monitoring. I will first go over the solution overview, then show you how to set up monitors, then talk about how you can use the synthetic data. You can use APM synthetic monitoring to proactively monitor the availability status and performance of your web applications and API endpoints. It provides a workflow that enables you to define monitors, either browser or REST API based, or scripted monitors to perform tests against your applications. These monitors are Oracle Cloud resources that can be scheduled to run from one or more geographical locations around the world. These locations are called Vantage Points, which are available publicly in Oracle Cloud data centers where APM service is available. You can also create your own Vantage Point in your OCI tenancy to ensure the secure execution of your synthetic monitor. Monitors collect metric data that includes information whether the monitor run was succeeded or failed, how long it took to complete, and also how fast resources were loaded during the execution of the monitor. And you can see this information in dashboards. It provides predictable results and validates the ability of your applications. You can also select to collect screenshots of what the browser loaded during the monitor run or capture network trace details for additional troubleshooting information. If your application is instrumented with an APM tracer, you can drill down from the synthetic monitor run to punch out to the Trace Explorer page and trace each request from the browser throughout the entire application stack. Next, I will show you how to create a browser monitor. A monitor can be created in the synthetic monitoring page in Oracle Cloud Console. This is also the page where you can see the status of the existing monitors. In this example, there are 5 monitors configured in this APM domain. You can see the status, interval, and number of vantage points for each monitor. In APM, there are 4 types of synthetic monitors you can create, such as browser monitor, which requests a single URL through an automated browser session, and scripted browser monitor, which also brings up a browser session but executes a Selenium test script having a sequence of recorded user requests. There is also a REST monitor, which executes a single REST call to a defined endpoint, and scripted REST monitor that executes a sequence of instructions against a defined REST endpoint that are stored in the Postman monitor script. Next, let's create a monitor. Click the Create Monitor button and this will bring you to a wizard. First, name your monitor and select the monitor type. In this example, I will create a browser monitor. Next, type in a URL that you want to test against with this monitor. Make sure you type in the entire URL, including HTTP. You can also specify a text in the Verified Response Content field, which you can use to make sure the right page is loaded. Click Next to move on to the next page. The first option in this section is to select Vantage Points, which you want to run your monitor. You can select multiple locations from the pull-down menu. If you already configured a dedicated Vantage Point that runs in your own tenancy, that will show up in the list too. Then configure how frequent you want to run the monitor by specifying the interval between the monitor runs. You can also select to enable the network collection option. This option executes a traceroute against the base URL of the monitor and provides a report of all hops that the request went through. In case your endpoint cannot be reached, this option provides valuable information to troubleshoot the network issues. Now we are all set with the required configurations. Click Next and complete the setup of the monitor. Now you have a monitor running, you can start analysis with the monitor's dashboard. The var chart at the upper left side of the screen shows the number of runs and whether they have succeeded or failed. And the one next to it shows the vantage points where the monitors were run. If you see the monitor is fading at all locations, you might have a connection issue towards your application. A graph in the upper right side displays execution time of the monitor. If you see spikes, that indicates some part of your application is not performing well. And to see more details, there are breakdown charts. Load time breakdown chart is closely related to the execution time. In this example, you can see a spike with blue color, which is indicating the AJAX calls are slowing down. In case of the network issues, the connection time breakdown graph can help you to analyze the root cause. The faders in the monitor runs can be caused by the SSL not being resolved or an issue in DNS. Also, a longer execution time may be caused by the delay in the connection. And looking at the list of monitors, the second monitor seems to be the slowest, also having a fader. So let's take a closer look at this monitor by clicking on the monitor name. In the history section of this monitor page, you can see all executions of this monitor. You can also filter the executions, such as the time range, or by the status, or by the vantage point. In the list, there is a monitor run that was taking a lot more time than others to complete. To diagnose what was going on with this monitor run, click the three-dot icon at the end of the row. This opens a menu that provides you options to analyze the monitor execution. So, for example, you can see error message coming from Selenium script in case of a failed script run, or trace details in case of network issue. You can also see a set of screenshots of the HTML pages navigated in the monitor, or download browser console logs. Here, let's review the HAR files as it may have information regarding why the pages were slow. HAR file, or HTTP archive file, stores information regarding user actions performed on the browser, and it is commonly used to troubleshoot web pages. APM also adopted to collect HAR files at the monitor executions and visualizes in this page. On the top left side of the screen, there is a pie chart showing almost 70% of the total execution time was spent on waiting. So let's scroll down to see if there's more information, and here it is. So it turns out that the page was waiting for 25 seconds on a single request, which is a post to checkout service. This is where the slowness was happening. So let's click the link and review the request and response header information. You may see something unusual in the headers that might be causing the issue. And there is also a camera icon at the end of the row, which opens a screenshot captured at the time of the monitor run. And this is where you see the error pages, such as an internal server error, in case of the failed monitor runs. In this particular monitor run, the screenshot shows the page was loaded successfully, but the page was still waiting for a long time for the checkout. In case of the slowness, you may need to drill down to the server side to find the root cause. So let's close this window and go back. Many times, reviewing the HAR files and other mentioned options help you troubleshoot your performance issue in web applications. However, in case the root cause is at the back end, it requires investigation in the application server. So if you have configured APM Tracer on the application, you can use the View Trace Details option to navigate to the Trace Explorer page directly from the Monitor History page. And here, open the Trace Explorer. Because we navigated from the Monitor History run page, the query was automatically created to display the result of this particular monitor run. Looking at the Gantt chart in the main section, there is a trace at the top row where it took 25 seconds to complete. This should be the request of the slow monitor run which we were seeing at the monitor page. Click the operation name to see the details. And from here, it's straightforward to spot the issue. One of the spans was taking 22 seconds. From the operation name, you can tell it is a JDBC span, and it seems to be a database update which was done as a part of the cart update in a checkout service. So this seems to be the root cause of the slowness, but you can also see the database related dimensions from the span. Click to open Span Details page where you can see the diagnostic details of the span, which includes database connection string or SQL ID that you may want to use to further diagnose the database. Moving on to the Chapter 12, Synthetic Dedicated Vantage Points. In the previous chapter, we talked about the synthetic monitors which can be run from vantage points, which are provided in the Oracle data centers around the world. In addition to those public vantage points, you can set up a private vantage point in your secured Oracle Cloud location. This is called a Dedicated Vantage Point, or DVP. Dedicated Vantage Point is a useful option when your application resides in an on-premise location or a secure network and cannot be accessed from the public vantage point. Or you want to test your internal applications which are not publicly open to the internet. And another use case is to test secured APIs for integration purposes. The solution to above use cases is to use the dedicated vantage points. You can set up a dedicated vantage point in your own tenancy by provisioning the template, which automates the deployment. By doing this, it will create a copy of the same public vantage point which we have in Oracle Public Cloud, but gives you a full control on network setup to ensure the access to your secured application. Next, let's see the architecture of the setup. In this architecture overview, you can see a secured environment with two applications, a microservice application and a legacy application, both running in a single virtual cloud network or VCN in Oracle Cloud. So these are the applications you want to monitor using APM synthetics. But since the apps are running inside the secured network, you cannot use public vantage point to run monitors publicly on the internet. In this case, you can deploy a dedicated vantage point in your Oracle Cloud tenancy. When deploying a dedicated vantage point, an Oracle Container Engine for Kubernetes, or OKE cluster, is automatically deployed inside your compartment. This connects to the VCN where your applications are running. The deployment includes Scheduler and Deployment Manager, which orchestrate deployments of individual monitors in your dedicated vantage point. When a monitor is created and scheduled to run on your dedicated vantage point, a Docker image is created that runs your monitor at the scheduled intervals. Once a monitor is executed, the dedicated vantage point will communicate with your APM domain and provide metrics, browser logs, network trace data, screenshots, and HAR files. Now let's see how the dedicated vantage point can be created. You can create a dedicated vantage point from the synthetic monitoring page in Oracle Cloud Console. If you're not an Oracle Cloud administrator, as a prerequisite, please be aware that you will need your administrator to create a policy which allows you to create a dedicated vantage point and grant that policy to you or to your user group. Please see the Oracle APM documentation for more details on how to set up policies. And before starting the wizard, gather the information such as VCN details, authentication token, APM domain OCID, and private data key of your APM domain. Please also check if the VCN, which you want a dedicated vantage point to run, allows direct communication to the APM domain data endpoints. If it doesn't, you'll need to set up a proxy to have the communication to go through. So in that case, you need to gather the proxy server information as well. Once these details are collected, you can start the wizard by clicking the link. In the wizard, follow the instructions to configure the entities such as VCN, APM domain, OKE, or proxy along with other information. And once you enter all the required configuration information in the wizard, the Resource Manager Stack Details page opens and starts the provisioning of the dedicated vantage point. This process will take around 45 minutes to 50 minutes to complete. And once the provisioning is completed with successful result, your dedicated vantage point is created. To verify, open the Create Monitor page or Edit Monitor page as shown in the screen. Then open the pull-down menu under Vantage Points. You will see your new dedicated vantage point, which you just created, in the list. You can use the dedicated vantage point to run your monitors within your VCN, within or connected to your protective environment. This is the end of the recording of Part 5, Synthetic Monitoring in Application Performance Monitoring Service in Oracle Cloud Infrastructure. Please find the links to other chapters of the APM tutorial series from the description in this video. Thank you for watching.